I am T.T. Vimala, Assistant Professor, Department of Computer Science, working in St.Josephs College of Arts and Science for Women, Hosur. Today my topic is 2D transformation from the subject Computer Graphics. Here we are going to see about the transformation, that is a 2D transformation known as a two-dimensional transformation in computer graphics. What are the transformations in computer graphics? So, translation, rotation, scaling, shearing and reflection. Before going to all this transformation, first we want to know what is the transformation. Transformation plays an important role in computer graphics to reposition the graphics on the screen and change their size or orientation. That means change the size or orientation. We have various type of transformation such as translation, scaling, up or down, rotation, shearing, reflection, etc. When a transformation plays on a 2D plane, it is called 2D transformation. Next is a translation. Translation is translating an object from one place to another place on the screen. That means moving an object to a different position on the screen. How we can do? We can do by adding the translation coordinate tx, ty to the original coordinate x and y. That means x dash equal to x plus tx and y dash equal to y plus ty. We can represent this as a matrix form as this p dash equal to p plus t. Here tx comma ty is a translation vector. Next, rotation. In rotation, we can rotate the object from one position to another position. That means we can rotate the object at a particular angle theta from its origin. In this figure, we can see the old theta is moved to the another position, that is the new, x new and y new. Here we can represent it in a matrix form, that is p dash x dash comma y dash x dash comma y dash. Next transformation is scaling. What is the scaling? Scaling is to change the size of an object. The scaling transformation is used. That means we want to change the size of the object. We can use the scaling transformation. In the scaling process, you either expand or compress the dimension of the object. That means you can compress or increase or decrease the size of the object. How it is obtained? The scaling can be achieved by multiplying the original coordinate of the object with the scaling factor. That means scaling factor is multiplied with the original coordinate to scaling. Scaling is increasing the changing the size of the object. Here we see how the scaling is worked. That is, we have the original coordinate is x comma y, then xx comma y is the scaling factor sx comma sy. Here we multiply the sx comma sy to the original coordinate x and y. X dash equal to x dot sx and y dash equal to y dot sy. Here we represent in a matrix form, that is p dash equal to p plus s. Here we represent the matrix is equal to p dash is equal to p into s, that is p dot s. If you provide the value less than 1 to the scaling factor, then we can reduce the size of the object. If we provide the values greater than 1, then we can increase the size of the object. Based upon the values given to the scaling factor, the size will be increased and decreased. Next is the reflection. Reflection is a mirror image of the original object. In other words, we can say that it is a rotation operation with 180 degree. In reflection transformation, the size of the object does not change. Next is a shear. A transformation that slants the shape of an object is called the shear transformation. There are two shear transformation, x shear and y shear. One shifts x coordinate values and other shifts y coordinate value. However, in both cases, only one coordinate changes its coordinates and other preserves its values. Shearing is also termed as skewing. X shear. The x shear preserves the y coordinate and changes the mate of x coordinate, which case the vertical lines or tilt right or left as shown in the figure. The transformation matrix of x here can be represented as y dash equal to y plus shy dot x. Shy is a shearing factor value. X dash equal to x. That means if the x coordinate x shear, the x coordinate will be changed and the process will be done. The y shear preserves the x coordinate and changes the y coordinate. That means which cause the horizontal line to transform into lines which slope up or down as shown in the figure. The y shear can be represented in matrix form as x dash equal to x plus shx dot y and y dash equal to y. Here the x value was changed and y value is not changed. This is y shear. Thank you.